So now let's find the inverse of f of x equals 2x minus 3. So first, y equals 2 square root of x minus 3. Then we want to switch the roles of x and y. So x equals 2 square root of y minus 3 divided by 2. So we have x over 2 equals square root of y minus 3. Then in order to get rid of the square root, we square both sides. So this becomes 1 over 4 x squared equals y minus 3. Let's add 3 to both sides. So g of x equals 1/4 x squared plus 3. Now let's think about this graph for a minute. F of x equals 2x minus 3 equals square root of 2x minus 3. So we should know how that graph looks like. So it's vertically stretched. Just to kind of do a sketch, it would be right 3, and then it would be stretched somehow. So it would look generally like this. Now thinking about what 1/4 x squared plus 3 looks like, what should that look like? Well, it's a parabola, and it starts at 3, right? And so it's a parabola, which that is not what I need. I only need a piece of it. So what piece do I need? So if you think about this graph, if it's supposed to reflect across the line of reflection, which is here, okay, so if I drew that a little bit better, through the origin, we would only need the right side of the graph. And so thinking about our first equations that we had earlier about solving the quadratics, okay? So what we're going to say is that we have to restrict it where we only want x is greater than or equal to 0. So when you're solving square root problems, you're going to have to remember to write the restriction. X is greater than or equal to 0 in this case. So pause the video, see if you can do number 9, and then also remember to write the restriction on that as well. Okay, so if you tried it out, so y equals the square root of x plus 2. Let's square both sides immediately. Y squared, oh, I forgot to switch the roles. So let's do that first. X equals the square root of y plus 2. Now we can square both sides. So x squared equals y plus 2 minus 2 to both sides. So we have x squared minus 2 equals y, or g of x equals x squared minus 2. So again, that is a parabola, so we need to remember to restrict it. Let's graph this real quick. So we know that the original square root of x plus 2, that is left 2 here, and then so it makes kind of this graph here, and this other graph x squared minus 2, so it's down 2, and then so remember it goes this direction, but we want to think about that line of reflection. So which one would make sense? So in this one, the one that would make sense would be only this right side. Okay, so that is when x is greater than or equal to 0. It's not when it's 2, right? Because I know you're thinking, oh, well, what about negative 2 here? Well, if we think about negative 2, then you'd be looking at this parabola, right? That's not a reflection of that graph. I'm trying to think of all the ones that I've heard of in class. If it was only positive 2, then we'd only have a piece of it. It would actually only be positive 2, would only be this part right here. So that's not a good reflection of that graph. So it is when x is greater than or equal to 0 in this case. Okay, so here's the new function, x squared minus 2, and x is greater than or equal to 0. Now if you don't trust me, I want you to see this problem number 9. I'm going to go back to here. This problem right here, example 3, x squared minus 2, and notice our g of x is the square root of x plus 2. We actually just solved for it, right? We started instead with the square root of x plus 2, and then we got the x squared minus 2 with the restriction of x is greater than or equal to 0. So that is the same.